zero this out. Sometimes it's the machine too, and you can
adjust it.
yeah. Something's definitely this machine, some bad readings. Yeah, one we're way over. And typically there's a couple of things you can try, but what it usually is, yeah,
there's something definitely wrong.
Yeah, if it's not the cord giving you an issue, which sometimes it is,
Okay.
just by wiggling the cord, you'll see a change. You know, but that's not what's going on. The other thing is that a lot of times the sound head or the holder is pressing down on this.
Mm-hmm.
And you'll see if you press down on it, it's going to change.
Mm-hmm.
You know, sometimes that happens. Something happened. Cone's not
there's
in.
stuff to do
exactly
before you freak out and say it doesn't
exactly.
work.
You know, and if
troubleshoot basically.
Yeah, you know, if that all seems to be in place, none of those things are interfering with that, you got a calibration issue.
Okay.
You know, and I will show you how to calibrate this machine. Okay. Ultrasound. Okay. These.
All three of them at the same time?
Yeah. And then stop. Butthole. Go over to the calibration mode. Now you'll see calibration.
Ultrasound calibration. You just press on that?
Yeah. So it's these three buttons.
Start.
And then these two buttons here.
Okay.
Make sure your meter's on zero.
Bring it
Zeroed
back to
out.
0. Okay.
Get an accurate reading.
And start calibrating.
That's the calibration. You'll start seeing these numbers start to fluctuate down here as it's searching.
So this is basically searching for a problem.
It's
kind of troubleshooting itself.
It's troubleshooting itself, yeah. And it's looking for calibration information.
Okay.
You
and
know,
then it gives you a reading. Just tells you what's wrong.
And it starts you off, you'll see, because there's boards in here. There's also a board in the sound head itself, so it's communicating back and forth with the sound head, trying to find the right frequencies.
Well, that's good.
Okay, So now it's telling you to set your meter to 4 watts. Okay?
Change it back to...
What most people do is they'll start spinning the dial or looking at the machine, expecting it to start showing wattage.
Okay.
No, pay attention to your meter. As you're ramping it up, you'll notice this starts going up. As soon as this meter
4 watts, you said?
reaches 4 watts, and it comes up quickly too.
Okay.
Usually right up around 300 to something 300. That's where you'll start seeing it start getting up close. And if you spin it too quick,
you might miss it.
You'll miss it. And it's kind of a pain to have to go back.
It's almost there.
Yeah. Well,
there. Okay.
It's very easy to go past it. You want it right on 4.
Okay.
Just kind of wait, make sure it's stable.
Mm-hmm.
And next. And I'll have you do it on 3.3 megahertz as well. And again, you're looking for 4 watts on 3.3 megahertz. There's been times where I've not paying attention. I've ramped it up and my meter's showing 10 watts. I'm going, oh crap. I go all the way back
all the
down.
Way back, start all the way
yeah.
down.
Good. And it kind of walks you through it.
Remove applicator from water. Okay. Next.
Let's save the calibration data. Once it's clear.
Okay.
You should be good to go. If it doesn't calibrate it again, and you're still off,
then you gotta replace something in this thing, right?
No.
No.
It's the board in this.
Okay.
And I'll show you what you need to do.
Okay. You guys replace the boards too, right?
Oh yeah, they're real simple. Right at 1. Right at 2. Right at 4. Just about right at 5.
Last one's 10.
Might go up to 9.4, but we're
should be,
within,
that's good.
yeah, we're still within the 10%.
Okay.
You know. Make a liar out of me, machine.
So freaking sensitive.
Yeah, they are. Gotta go back up a little bit. Okay.
It's going wild.
Yeah, you'll get some wild numbers. It will settle down once the water stops moving. Yeah. Okay.
That's good, right?
Yeah. We're right good. Okay. So it did calibrate. It's usable.
Everything's okay.
Yeah. I've got a sound head.
Okay, so at this point we're ready to do a flow test. I wanted to show you a quick rundown on how I have everything set up. I currently have my distilled water in a bag with an IV line currently punctured in, as you've seen. The line is already primed and ready to go. I have that connected directly into the channel and it's ready to be infused. Now the other end of the line, on the patient side, I have it open and it's connecting to this three-way port with the syringe. Now I currently have the port for the infusion pump closed because I'm going to need to use the syringe on my IDA1S flow analyzer first. Now on the analyzer itself, I have it connected to the bottom inlet, which is designated for flow, and on the opposite side we have a where the water exits, I have it connected to a beaker, and we're actually going to use this beaker because it measures in milliliters. We're going to see just how close we can get to an actual infusion that we've set. On the IDA1S, we have a real simple setup. All we need to do is hit flow on the test. We would put in any patient name if we had any. We're just going to skip through. We're going to connect the pump as it requests. We already have, I just showed you that. And the most important thing here is notice the red bar. That tells you the device is not primed. This is where the syringe comes in. So as I press on the syringe, you'll notice that the blue bar, or the red bar, shows up as a blue bar. There it goes. And once it is completely blue, you're actually ready to go. Don't forget to change your switch to close the syringe and open your infusion device. So at this point, all we need to do now, I'm going to start my infusion device and I'm going to start the test at the same time. Start and start. We should see some numbers coming up shortly. There they are. That lets us know the device is currently functioning properly. And another thing we can do, we can actually test our theory here. You can see the water dripping into our beaker. So this should take about 10 minutes. I'll come back here in just a few minutes and see where we're at. Okay, so now that the infusion is complete, we could take a look at some of the numbers we have on our screen. As you can see on the right, we have 30.21 volume in milliliters infused. Our original was 30 milliliters set on the infusion device, so that's looking good. And on the left, you can see in the large numbers we have 180.94 milliliters an hour, and our set rate on the infusion device was 180, so that's looking good. One other thing that I did do intentionally, I added an air bubble just so you can see that the device does show if any air bubbles come through, which may mess up the measurement. Now looking at the beaker, you can see that it's very close to about 30 milliliters, which is right on point. If I go and I weigh this, and I weigh it on the scale here, this scale measures in grams. Now it needs to actually be zeroed out again because it's showing 112. It should be 114. There we go. And if I go and I weigh, due to the fact that this is distilled water at room temperature, you can see that it's showing 30 grams in weight. So we're right on the money with this. Oftentimes in hospitals you'll find that a lot of clinical engineering teams will actually just use a scale to actually do their flow tests. So it's very important that you know how to do a measurement in grams to milliliters. And that's it, guys. That's all I have for the infusion device. Thank you.
Patient monitor testing can be quicker and easier than ever before with ProSim 8 from Fluke Biomedical. We're going to do a patient monitor test, and we're going to try and do a complete but quick test of this patient monitor. The parameters we're going to test are ECG rate, respiratory rate, invasive blood pressure, channel 1. We're going to do a cuff blood pressure and IBP measurement and oximetry. We're going to try and get all of this testing done in under 5 minutes. As you can see, there's a digital clock shown in the lower left-hand corner of the patient monitor display. So you can be your own judge as to whether we can get through this test within 5 minutes or not. So as I begin the test, we are already connected to the device under test. All of the connections have been made ahead of time, including the NIBP cuff. And we are going to zero our invasive blood pressure transducers on the patient monitor at the very first step of what we do, followed by a selection of a simulation of all coordinated patient parameters. We'll do hypertensive first, followed by normal, followed by hypotensive, in order to assess whether we have a performing patient monitor. We will compare the displayed values on the ProSim 8 against what's displayed on the patient monitor at each set of simulated parameters. Are you ready? Let's begin now. First thing I'm going to do is 0 P1. It is at 0. And now what I'm going to do is pick hypertensive. And the simulation will already begin, so I'm going to start a blood pressure, cuff blood pressure reading. In this case, we're looking for an ECG rate of 130 beats per minute, respiratory rate of 40. We're looking for an invasive blood pressure display of 200 over 150. We're looking for NIBP of 200 over 150 with a mean of 167, and an SpO2 reading of 90. And it looks to me like we've got all of those on the patient monitor. 130, invasive blood pressure 198 over 149 with a mean of 167, and we have 90 O2 sat and 197 over 142 with a mean of 165 on the cuff. Let's move to normal. The normal simulation includes heart rate, ECG rate of 60 beats per minute, a respiratory rate of 20 breaths per minute, invasive blood pressure of 120 over 80, a cuff blood pressure of 120 over 80 with a mean of 93, and SpO2 at 100% O2 sat. As you can see, the patient monitor is already displaying 60 beats per minute for heart rate. It's gotten 119 over 79 with a mean of 93 for invasive blood pressure. And the cuff is making its measurement now for the O2 sat, or for the NIBP reading. O2 sat is 100%. There we go, 121 over 77 versus 120 over 80, pretty good. We'll go to hypotensive now and start another cuff measurement. We're looking for an ECG rate of 40 beats per minute, respiratory rate of 15 breaths per minute, an invasive blood pressure measurement of 50 over 20, and cuff blood pressure of 50 over 20 with a mean of 30, and an O2 sat of 97%. You can see that the ECG rate on the monitor is already 40. Our invasive blood pressure is 50/19, very close to 50/20. Our cuff is working on getting its measurement, and the O2 sat is 97, right on with what we asked for, what we're simulating. We started at 18:55 and 44 or 45 seconds, and we're going to finish very shortly here. Done. And we have good values. As you can see, it is possible to do a complete, quick assessment of patient monitor performance using ProSim 8 and front panel controls in under 5 minutes.
Meet the next generation electrosurgical analyzer, the Fluke Biomedical QA-ES3. This all-in-one analyzer offers improved functionality, accuracy, and ease of use over its predecessor, the QA-ES2. The QA-ES3 collects all measurements including vessel sealing, high-frequency HF leakage, contact quality monitor, and output power distribution in single or continuous mode. It also measures cut and coag waveforms with either monopolar or bipolar outputs. The automatic power distribution feature allows automatic measurement of power, current, peak-to-peak voltage, closed load only, and crest factor. The addition of automation speeds up testing and helps reduce human error. At first glance, you'll notice the QA-ES3 has been redesigned to reduce the number of connections. All of the multi-purpose ports are accessible from the front, along with function keys and the selection knob. The large LCD screen is easy to read, and on-screen guides are designed to guide you through testing. When you pick up the QA-ES3, you'll quickly discover it's lighter than the previous version, 5.5 pounds lighter. Everything you need to test all critical functions of today's high-power electrosurgical units is either integrated into the design or included with the unit. There's no need for extra cables, leads, or switch boxes to test precision power, current, frequency, crest factor, and load resistance ranges. The state-of-the-art technology, the QA-ES3, provides exceptional accuracy and range of measurement. Its wide range of loads allows users to test the breadth of electrosurgical generators. Notably, the QA-ES3 has a 20-ohm load to support Valley Lab electrosurgical units, including the Force Triad. The QA-ES3 also has double the RMS current range of its predecessor. It can measure current from 0 to 5,500 milliamps. Plus, it's twice as accurate with current accuracy, 2.5% of reading, plus 1 milliamp for all loads. It's exceptionally accurate with generator output power accuracy of 5% greater than 10 watts and 5% plus 1 watt otherwise. In addition, it provides a load resistance accuracy of 2.5%. The QA-ES3 is also highly precise with a 1/10 of a watt resolution up to 99.9 watts and 1 watt above 100 watts for power measurement. Featuring a universal power supply and in compliance with global standards for testing electrosurgical devices, including IEC and ANSI/AAMI, the QA-ES3 can be used worldwide. It can store up to 5,000 records, making it convenient to store results and retrieve later. Also contributing to the QA-ES3's reduced test times is its Bluetooth wireless capabilities, which makes it possible to quickly and conveniently transfer results to a PC. The addition of Answer software further automates and standardizes testing, speeding up overall test times and minimizing human error. Answer software can produce a single electronic test report, which displays all preventative maintenance tasks, including visual inspection, electrical safety, and performance characteristics. The QA-ES3 is an all-in-one analyzer to get the job done accurately and quickly. With industry-leading specs, the QA-ES3 can test all modern high-power electrosurgical units.
Introducing the ProSim Spotlight SpO2 functional tester, the newest member of the ProSim family. The scenario that we're going to talk about today is one that happens every day in the medical facility or hospital, where you get a call from the clinical unit, the oximeter is not working on some medical device. So you grab your Spotlight and you go up to the clinical unit. In this case, we find the device turned on. It's a defibrillator, and we will turn on our Spotlight SpO2 functional tester, wait for it to go through its self-check, and we will then connect the oximeter sensor from the medical device, and we'll watch this bar down at the bottom. It's called the signal strength bar, and you can see that it has a good signal, and you will begin to see the display on the screen of the defibrillator. Now, testing this functionally really quickly is just a 4-button push. We're going to go to our custom setup and go to custom 3, which is programmed for a patient with a high heart rate and a high O2 sat. You can see it sets off the high limit alarms, which is exactly what we want it to do. We'll watch till the oximeter reading and the heart rate settle. And then we'll move to custom 2, which is a normal patient. We want to let the alarms continue to sound because the normal conditions will let them silence on their own, an important part of the functional test. Again, waiting for those to settle, and then we'll simply push one more time for our hypotensive patient with a low O2 saturation, low perfusion. And you'll see the alarms will sound again, this time on the low end. And again, we'll wait for the readings to settle. And we'll push one more time to get back to a more normal reading so the alarms will quiet once more. And there we are. You've tested 90% of it in right around 30 seconds. The SpO2 functional tester, Spotlight, the newest member of the ProSim family.